Starting, all attendees are in listen-only mode.
Good day. Welcome to the monthly Conexxus webinar series. And today we're very happy to have Scott Cheek and Alex Barclay, both from SageNet, to talk about lessons learned with Internet of Things and the API integrations. Our agenda today, I'll go through a few housekeeping items. We'll introduce our presenters, talk a little bit about Conexxus, go through the presentation, and then finally we go through questions and answers. Just want to remind everybody that the webinar is being recorded and it will be made available in approximately 7 days. You can find it under YouTube if you look for the subscription of Conexxus Online, or you can go to conexxus.org under Resources and Webinars. Also, the slide deck will be available upon the conclusion of the webinar. You will receive an email asking you to fill out just a few survey questions. And upon completion of that survey, it's only like 3 or 4 questions, I promise. It's not much. And we really want to hear what you want to hear about next month. Once you complete that survey, then you'll get another link to the presentation. All attendees, as the GoToWebinar person said, are in listen-only mode, and so we ask that your questions be typed into the question interface in the GoToWebinar panel. Please note specific vendor questions, and if you do need continuing Edge credits for your PCI, please contact Ali Russell at conexxus.org. And if you do have any questions or comments, please contact info@conexxus.org. Our host today is Ali Russell. She's the standards coordinator with Conexxus. I am your moderator, Kara Gunderson. I am the chair of the Data Security Committee for Conexxus, and by day I work for Citgo Petroleum. Today, as I mentioned earlier, we're very excited to have our speakers with us, Scott Cheek and Alex Barclay. And so I'm going to ask each of them to just give a brief introduction and a little bit about their background. So Scott.
Thanks, Cara. Again, hi, it's Scott Cheek. For those of you who I have not had the pleasure of meeting, I've been kicking around the industry for about 4 decades. Spent 23 years of that at Sunoco as the director of store technology. Back in the early days of PCATs, very involved in the loyalty standards, and was worked to sort of get our grocery to C-store loyalty programs off the ground, as Sunoco was one of the leaders or early leaders. For the folks that Shell are on the phone, yes, I am still bitter that you bought past us, but none regards. We did a lot in that area and spent a lot of money with Gilbarco and Verifone and Wayne or Dover at that point in time, and glad to see that Gilbarco offered up their standard as one of our first big PCAT standards back in the day. So I sort of feel like where we are with API integration today sort of harkens back to those days. Since I left Sunoco, I spent 3 or 4 years as a consultant. I was a longtime customer of SageNet and came on board as their director and vice president of business development and channel. SageNet has about 220,000 endpoints under management, and we have a core focus area on connectivity and firewall management. We have a broad digital signage portfolio, as well as through some acquisitions, a cybersecurity platform and program, as well as a big data managed Wi-Fi solution. So that's a little bit about my background. And Alex, do you want to introduce yourself?
Yeah, good morning, everyone. My name is Alex Barclay. I've been a product manager with SageNet for about a year. My background is computer science. I'm a systems and security computer scientist. I focused my career on enterprise computing, high performance computing, and product management for startups in the IoT SCADA world and for networking startups. So I'm super excited to talk today and look forward to your questions and as we move through this content.
Thanks, gentlemen. So a little bit about Conexxus. I think Scott gave a great introduction about the legacy of Conexxus. You know, they started as the next technology arm and became PCATS and now are Conexxus. And they are an independent, nonprofit, definitely member-driven technology organization. As you can see, Scott and Alex are volunteers. Scott was volunteer for the very first loyalty standard. I'm a volunteer as well. And so Conexxus is all about the standards, about data exchange, security, mobile commerce. They really provide the vision for emerging technologies, for trends. And you can also find them at other industry and association meetings and participating in those as well, because they're very, very much an advocate for our industry. We've had some great webinars, and so again, you can see and have those replayed at your convenience under conexxus.org or under the YouTube channel. And we've got some great webinars coming up as well. And we're going to talk about ransomware in October and real world scenarios that impact PCI compliance in November, as well as the step-by-step approach for automating that security response. And I think on the top of mind for a lot of folks is EMV. And then all the way into January, we're going to talk about securely connecting those third-party vendors. So again, by completing that survey, giving us ideas as far as what you'd like to see in the future, we'd love to hear from you. Very important to Conexxus are all of the sponsors, and listed here are their 2020 Diamond sponsors. And so we really want to greatly thank all of those folks that contribute not only their time and their talents, but also financially to the success of Conexxus. So with that, I'm going to turn this over to Scott and Alex. Thank you.
Great, thanks again, Cara. So we can move on to the next slide. So what are we going to talk about today? Again, you know, speed of change continues to, if you will, accelerate. We're going to talk a little bit and sort of set the table for what has happened to us and what we needed to do in order to react to those type of issues. You know, the COVID period, the dynamic shifts in the customer, the business dynamics. You know, we're all in the world of problem solving. You know, we need information. Our customers are looking for information because what? The test, fail fast, change, rinse and repeat is, you know, it is the way that we are living and breathing and helping our customers today. Next slide. So I like this slide. So, you know, that could be Albert Einstein, or that could be the crazy scientist from Back to the Future, or as my grandkids say, oh, there's Pop-Pop again. You know, my God, let's make sure that he's got some soft way to land. But the bottom line is we all are riding this bicycle and we are trying to change things while we are moving. And we have never had to move faster. So it's all about the speed and being able to do that nimbly and smartly. Next. So for those of us that participated in the leadership conference that I just thought was great, Gray did a great job of leading that along with the Conexxus staff. We had great speakers. This particular data comes from Coupon, but a lot of it was called out in the leadership conference. So we know that if we look inside at the COVID hit, what happened? We had a tremendous fall off in gasoline volume as people were staying at home. Margins were really great, but again, we had in some cases big drop-offs in volume. We got impacted, immediately with the physical distancing and mask. How are we going to get that to our stores? How are we going to enforce that with our customers? Each territory, each region really was different, whether we were in a city environment or whether we were out in the country. Different people had different thoughts. We all had to be very nimble. The teams, our customers, had to make decisions on the fly. The trips to the inside of the store were down, but basket size was up. How do we get basket size to continue to grow? And we're all stressed out. So as we heard in the seminars, you can use this on your Jeopardy call of the day. What were the two biggest basket item increases during COVID? Well, alcohol and cigarettes, right? No surprise. We were self-medicating. We customers were looking for a touchless experience. We had to immediately come up with opportunities for drive-through or curbside. Next slide. So, we've seen this in the news, and these are just a couple examples. Obviously, Wawa, Cumberland, were published here, but we could say Come and Go. We can say Quick Trip, no matter how you wanted to spell it. We can talk about Sheetz. We can talk about Casey's. It was not just our normal top tier that we reference, but basically everyone was trying to accommodate the needs of their customers and to try to do it as quickly as possible. Next slide. So I can remember, we've all heard about, Wawa. Here's the first picture of, it's not built yet. There's one that's going to be in my backyard. I'm dying to go there. But, a lot of folks have been testing drive-through for years. And so it's not a new concept. It's just, it's the only concept that they're going to be drive-through. I can remember a dairy store in Delaware County outside of Philadelphia where you actually literally used to drive through the store. So like a beer distributor, you would drive in, you'd talk to the attendant, you'd give them your list, they'd fill your trunk. So it's not something that's new. It's making something that's old new again in a different way. So next slide. So where does this leave us? In a nutshell, we're living in two different worlds at the same time. We have a large percentage of our population that is trying to do business in the old world, and we now have a certain percentage of our customers that expect us to be doing business in a new way. Next slide. So let's just think about these tremendous shifts that historically might have taken a considerable amount of time that all came upon us at this period of time in our history. So unprecedented health concerns, right? We've lost 200,000 souls. The financial uncertainty in the market. Are we going to get the second round of stimulus or won't we? We can't take our normal 4 or 5 years. We've been talking about EMV outside for how long? Since 2013, right? We're still not there, but yet we are being forced to do things that used to take 5 years on a dime. We need to be agile because we need to be able to test this stuff and provide information to our management and to our customers so that they can make decisions on the health of their business in almost a real-time basis. And what's our role as technologists? What's our role as information providers? Well, we are there to present the facts in a calm way so that our customers and those that we are advising can make the correct decisions on the way to move forward. So what are those, if you translate those 6 paradigms, what are the 6 needs in the next slide that we know that we've come across? Okay, this pop-up connectivity anywhere. In healthcare, it was the COVID testing or the expanded need for more hospital space for patients, where we were doing only indoor dining. Now we've got to do outdoor dining. We've got to be concerned about that. How are we going to, as we put up the pop-up connectivity, how are we going to expand our cybersecurity platform to be able to do all that safely? What do we need to implement from a signage standpoint so our customers know what to do? In order to have pop-up connectivity everywhere, we need to expand where Wi-Fi is enabled. We need to be able to potentially have staff augmentation, because to move at this level of speed, some of our customers need more help in doing that. And it all comes down to the data, right? In order to do all that quickly, in order to do it all efficiently, we need to be able to provide the data that's needed, because the operations and the marketing teams that used to want 6 months or a year to tell whether their program was winning or losing are now looking for that data in 30 to 45 days. So I've sort of set the table, and again, I'm here to basically offer the how the marketing and operations folks have been impacted. Obviously, Alex is the smarter, younger version who's going to take you through the technical things that we've discovered. So Alex, take it away.
Thank you, Scott. So when we look at all these shifts, and there's a lot to take in at once, these shifts right now require APIs. And these APIs can be used to free data from the silos that we all experience in our environments, to integrate different systems so we can try out different things to meet our consumers' needs. APIs are also great to perform A/B experiments, evaluate how one store does versus another store by using data and sensors to figure out what is going on, to then reinforce the rest of your business with lessons learned. APIs are also used to understand the business in real time, not just batch like it was 5 years ago, 10 years ago. APIs also are needed to use sensors to change behavior of customers and employees. A good example is you can have a sensor that evaluates how long an employee washes their hands. You can then flag that and say, hey, you need to wash your hands more. And so all of these functionalities of APIs are really help with those shifts that we see. The other thing is, as cloud becomes more important, APIs are required to move to the cloud, because the cloud really is API native. And we see that when you combine the cloud plus business information and APIs that can do things, you can craft complex capabilities and automation. And once you do that, you can start to save money. And in the next slide, let's actually talk about what is an API. And we've purposely not gotten into the technical geeky details because that's probably the least important part of this talk. But an API at a high level is a rule for communication between two parties. Sometimes it's person to computer, like when a software developer is using an API locally to check on the status of something, or it's computer to computer, which is how most people refer to APIs. And this is where one server that we control maybe reaches out to a vendor portal that someone else controls to transfer information. Developers use APIs to write software. Most of the time, developers are using API to write software locally or now with web services. And these APIs are used to communicate, and they're pretty simple because APIs read something, write something, or do something. And APIs can vary from incredibly simple to very, very complex. And we see in the next slide a perfect example. So how does a web API work? A web API works when a client, one computer, or a human, like me in front of a web browser, makes an HTTP request to a web server. The server then figures out what am I trying to get and returns the content that I need. If we look at the next slide, here's a very simple example of one previous. Here's a very simple example of what a web request looks like. Going to Conexxus.org is me inputting Conexxus.org, getting a piece of data back. That is exactly how most web APIs work. As we see in the next slide, this is an example of of an API endpoint. One is saying, okay, get Conexxus/API/user, and it's returning, as opposed to a web page. If you just go to Conexxus.org/index.html, you get in this case, a JSON object that returns the information. Oh, great. The ID of the user is 1 and their username is 1. We can extend this. If you see that same sort of API structure, just kind of like a website or a REST API, we can see, hey, don't just give me the user ID, give me the address for this user ID that I give you. So that's how we can get data from APIs using the REST API interface, which really is kind of a newer version of the World Wide Web. And the next slide. So the nice thing is we get to talk about some fun scenarios. And these are scenarios that I've used APIs at previous companies, at this company. And my goal of these scenarios is there's 5 of them, and I'm hoping to have something for everybody in this audience here. So this first scenario is pop-up connectivity data use alerting. What do I mean by that? At a previous job I had, I think it was 8,000 modems. And some of these modems were on the public internet as opposed to using like an APN or a virtual private network. The challenge was those modems got hacked by different types of malware. One was Mirai, one was IO Trooper. And so after realizing what was going on, we had to get better reporting on when modems are misbehaving. So we needed to look at the spikes of data use, but we couldn't look at the vendor portals for spikes of data use because they were about 12 to 24 hours behind. So we actually had to look at data use on the modems themselves. And this was a really simple project where we used Python to basically iterate through an Excel document of all of our modems. We then collected status from those modems, and then we ran another Python program using a Linux cron job. It's a way to schedule tasks. And what we were able to do is spit out, I think it was every hour, what modems are using too much data. And the nice thing is, because we were using those APIs, we were able to really prototype this in a few man days. I had an intern write the first version of that, and that's because that's how simple APIs can be at times. So if we look at the lessons learned for this use case, next slide, Pete, please. There we go. Even though we had an intern prototype this, it took some time to mature this. And the reason why is the modems or the gateways were from a variety of different eras. And API standards and best practices, or API design standards and best practices have changed over time. So what we saw that was there was a lot of variability in our modem fleet, and that some of the APIs, because of the capabilities of the modem, worked very, very slow. The other challenge that we saw with this pop-up data use alerting was a lot of the modems that we expected to be online weren't online. That's kind of the nature of cellular. This was an oil and gas field, and so we had those are out in the middle of nowhere. So we had probably about 20% of our modem fleet when it was raining or something like that that we couldn't access. The other challenge that we had was each of our modems each of our mainstream modems that we had different API compatibilities. So we had one series of modems that had a very modern feel of an API. We had an older series that that didn't work as well because the APIs were not as mature. And the challenge when we're talking about connecting to lots of modems directly is that multiple vendors don't have consistency in API standards. That's one of the things that I love about Conexxus is trying to have single sets of standards for vendors so we don't have to reinvent everything on the vendor end or on the client end all the time. So the other challenge that we had was even though some of our modems supported alerting features, most of our older modems didn't. So we had a very different set of capabilities between our devices, which made it challenging to be consistent in how we interacted with those devices from our server. One of the biggest lessons learned that I had here was using the modem management portals. In the Sierra Wireless case, this would be something like AirLink Management System. With Cradlepoint, it would be NetCloud. If you can use those as your API targets as opposed to individual modems, in theory, you may be able to get the same data, but through more established data paths. And if as those vendor portals become better, we can, and as those vendor portals become closer to real time, unlike the carrier portals, those would have been a much smarter way for me to develop that. So if we look at the next scenario, excuse me 1 second. Sorry about that. So if we look at scenario 2, all of us have been either the security team or the IT team saying, we need these logs in this location so we can analyze data. And the challenge with that is sometimes with air-gapped networks like SCADA devices out in the field, the logs can't easily be forwarded to a standard security event manager. So what we had to do was get the local logs off devices and put them in the security event management system. So how we did this was we did another Python service running on Linux to run a scheduled task to log on to remote devices, grab those devices, and then use the Windows and Linux native logging capabilities to then transport those logs to a customer security monitor. This project took about a man week. This was not with interns. This was with real developers. And the challenge here that we see in the next slide is that it's a much more complex system when we're dealing with getting logging from lots of different devices, because that we had to use jump boxes, and those jump boxes were good, but they were a failure point. And when we had those jump boxes, the jump boxes weren't necessarily stable in the environments that we were putting them in. So that's a consideration when you're working with isolated networks, trying to figure out how do you bridge security and IT. You may want to consider putting a small web service or a small API plus collection service together to get those remote security logs. The nice thing is this project was deployed and it worked really, really well. I believe that company is still using it today. So just think that when there's a challenge, the typical way of local devices forwarding logs or going to a central log collector, that may not always be available. But using APIs, you can overcome that and be creative in how you solve problems. And feel free to ask questions about these scenarios in the chat. I'll see them and be happy to answer them as we're going through them. So let's now look at the third scenario. This is kind of a really interesting one, and one that we as a company are working on right now. But we have customers that say, we need to measure employee temperatures before they come to work. And the reason for that is some states like Oklahoma have laws where if you can prove that you're following CDC best practices, you can basically not be sued for exposing people to COVID. So a way to do that is you have to prove compliance. And so we've been investigating camera and thermal sensor systems that would record the employee, record the name of the employee, and write that information to a database and show that temperature to an employee via digital sign or other mechanism. So how we're thinking about this is a C+ application running on a digital signage media player that is then connecting to that integrated camera and thermal sensor. From there, display the temperature to the employee via the digital signage display, and then store that really compliance data in Amazon public cloud to be able to retroactively prove compliance. This is one that we're working on now and working through now. So we're still trying to figure out what this means and what the challenges are. But we're expecting that this will be a few weeks to prototype, and I'm not sure how that text got cut off, but a few weeks to prototype, and it should be in a state that we can start testing it with our customers, which is pretty exciting. If we look at the next slide on what we've learned from this so far, is that there really are differences in API capabilities. In the enterprise software world, we generally say it's about 10 years for a piece of software to be mature. And I think the challenge that we're seeing with a lot of these IoT devices is they're 1, 2, 3, 4 years old and are still maturing and maturing their core product features, maturing their integrations with other products, and maturing their APIs. So early on in a IoT device's lifecycle, I expect the API to be changed about once a year, but after about 5 years, I expect the API to be changing about once every 2 or 3 years. The other challenge that we have with APIs in this use case is error handling. We have a lot of different system components talking to each other via APIs, and so there's a lot of different failure modes. So the question becomes, how do we best address those failure modes? Do we address that from looking at the operating system logs on the player? Do we create a service to get those errors centrally and then be able to have some central management of those errors? And so that's been a challenge in part of our conversations there. The other very interesting thing from being in this IoT world, in this industrial IoT world, is there's a difference in the quality of sensors. And in this case, we're talking about thermal sensors, but in other cases, we're talking about downhole well technology. And the challenge is garbage in, garbage out. And if your sensors aren't great, your output's never going to be great. So that's kind of one of the challenges that we have with temperature alerting, is making sure that we're going past what the vendors tell us and doing due diligence and validation of that. The other challenge that we have with that, and this goes back to, how fast the world is moving, is does this integration even matter anymore? We saw a lot of customer requests for this about 3 months ago, but since then, we haven't heard anything more, as I think the world has transitioned COVID from an unacceptable risk to a acceptable risk using masks and things like that. So so those are the types of things that we're trying to discover right now as we implement this technology. Next.
So Alex,
slide.
this is Cara.
Yeah.
We had a couple questions come through on scenario 3, because I think it's very timely to ask the questions while you still have this, plus you can probably grab a breath. Do you need to get any approval or signature from the person or the temperature subject, or the person you're getting the temperature from, to be compliant for other reasons such as HIPAA?
That's a really good question. And from my background as a HIPAA privacy and security officer, I would generally say no. HIPAA is generally restricted to entities that perform interaction or intervention medically, or insurance companies. So I'm not sure where temperature monitoring of employees stand. My feeling is that's probably going to be a per state legal matter. But when we see and look at some of the different guidance from CDC and other policy making organizations, they have been suggesting to temperature check employees. So I think that's kind of one of the challenges that our customers have as they're trying to evaluate this technology is what is legal, what is the best practice, and does this matter? Any more questions?
Yeah, there was one more too, is that were there multiple points of reference? And I think what they're asking is, how did you handle false positives also?
Yeah, that's a really good question. We're still working through that. And right now we're focusing on the integration part, not necessarily handling, going back to the goodness of the sensor. What happens when that messes up? My feeling is that's going to be conversations with our customers to develop some procedures for them to then do a double check based on what the temperature sensor shows.
Yeah. And those sensors, I assume, are online so that you can monitor that, and that's part of what you're doing, right?
Right. The sensors, think of them as giant webcams that also have another little chip that will measure temperature. So they're Ethernet devices. The ones that we're looking at kind of look like two eyeballs looking at you. One is a camera, the other is a temperature sensor.
Cool. Okay, thank you. That's all the questions for now, so we'll move on to scenario 4. Thank you.
Awesome. So this scenario is really for the networking folks in the audience. So this is and to support that Wi-Fi everywhere scenario that we talked about in the beginning of the presentation. So a good example of how to save money with IT is automation. And the problem that I experienced in a past life was we had a compliance and security mandate to change the VPN configuration on many devices. And the reason why we did that was we had auditors saying, hey, you need to be better at this and have more modern encryption. The other thing that we wanted to do was many of those devices were a little bit older and they were approaching their CPU limit. So we also wanted to change our cryptographic algorithms to be more performant, and so we didn't have to upgrade and have the cost of all these new devices. So what we were able to do was automate new configurations for these devices, and this was kind of a mix of sort of big name branded routers and Linux devices on a network. So we were able to use a web API on some of the devices or SSH on different devices to change the cryptographic policy. So we had to change the device configuration, all the devices out in the field, sort of multi-sites like what we see in the C-store case, and also the head end. So what we did was a collection of scripts, bash scripts, Python scripts that used SSH and configured StrongSwan, the IPsec broker. And those scripts were developed over years, but we at SageNet or any of your companies can replicate scripts like these in a matter of days. The nice thing is there's a lot of open source tooling out there to help manage networking devices. So in the next slide here, the challenge that we had by looking at across lots of devices with different technologies was we had inconsistent naming. So one device may be, Tulsa 1, another device may be 2 Tulsa. And so that inconsistent naming really hindered our ability to automate because we had to care about the weirdness that humans did in naming. And so that made our programming a little bit more complicated with lots of if statements to try and figure out which naming style was used at which location or which device. The other part about changing VPN configurations live is it's a little bit risky. And the worst case scenario would require a truck roll if we didn't get it right. And there were some cases as we were dealing with thousands of devices that we didn't have the right logic in our tooling. So we killed a device and accidentally removed it from the network. And I learned very quickly that our software had to be better because of those physical impacts of weak software. The nice thing about this project was we were able to also automate some of the testing that would have happened if we were changing configurations by hand. So there was a test suite and a configuration change suite. And running both of those, we were able to really save a ton of money versus doing it manually. So that was a huge win. The other thing that was a huge win was because different encryption algorithms require different number of compute cycles, we were able to avoid hardware upgrades for about, I think it was $250,000 worth of devices. So it was pretty, it was a big win for us. So that was kind of how, this was a really fun project that we got a lot of business benefit from. And if you're on the networking side of the Conexxus audience, automation is going to be the tool that unlocks productivity and really does save a lot of cycles for your staff. And feel free to ask any questions. And do we have any questions for number 4?
We do. Oh, actually, one just came in. Did you think about first automating the gathering of data to create a risk list? And from there, you can address, quote unquote, good name devices and a game plan for the so-called bad name devices, separating some of that functionality.
Yeah, in retrospect, that's absolutely what we should have done. This was kind of an urgent task because we were going up against an audit, so we didn't really do enough due diligence, to be honest. But what we should have done is invest a little bit more in that specification part, and that was also a very good lessons learned from that project.
Okay, thank you. I know we can't ask vendor-specific questions, but there was a question that came in about recommending a particular network automation software. So I think we'll, do you have just maybe a handful that you could rattle off?
Yeah, what was the question again? I'm sorry.
Do you have any recommended particular network automation software?
Let's follow up with that one via email or because there's a lot of good automation software out there. Okay. I don't know I don't have a preference on what's out there right now, but I'm a little bit behind the times in what's modern there. But we'd be happy to take that as a follow up and get back with you. Okay,
thank you. And that was it for scenario 4. Thank you.
Awesome, I appreciate it. So this next scenario is related to a product offering that we have, which is where we're using Wi-Fi analytics to measure market sizes and to measure number of consumers going near and in a location for marketing and sales. So the problem is really, can we measure traffic for a mall customer so they can adjust prices for their locations or sell their individual store locations to new customers. So this I think is a really good example of the power of APIs to do something different and to provide a lot of business value. So what we do here is we get a real-time feed of Wi-Fi client information, sort of MAC addresses from Wi-Fi devices, and we triangulate them. With that triangulation, we overlay it onto a map, and then we can also do statistics based on where we see Wi-Fi clients, and then provide those statistics to our end customer, who then give those statistics to their prospects. So this is a really cool application of this of APIs, like I said. And what we do here is we use C# and we pull Wi-Fi location data off a set of Wi-Fi access points. And then we also have an analytics front end to then look at that data in different ways. So this is the effort here I think initially was weeks to prototype, months to develop, and then sort of a year plus to productize. And if we think of that weeks to prototype and months to develop, that really is focusing on getting the data from the access points, understanding how to triangulate it, and then storing that data. The productization effort here really is building that analytics front end. That's what's taking the most amount of time. And as you guys work on your API strategies, visualization and analytics take a lot of time to do right, and they take a lot of developer cycles. A potential way to shorten those developer cycles, especially for proofs of concept, is focus on getting the data that you need into a database, and then pointing business intelligence tools like Microsoft Power BI or Tableau or Spotfire. I'm trying to remain very vendor agnostic here at your data pool, and that can give you a lot of the benefits of custom front-end development, but really with a very short development cycle and a very light investment from a developer standpoint. Let's go to the lessons learned here, because I think I'm already talking about some of them. So some of the lessons learned in talking to our developers for this one is what we get from the location API, or do we have a consistent definition there? One of the challenges that everyone has with APIs is you're getting data, but is that data well defined? Or you're getting information back from the API, but do you really know what that information means? Or are you taking a guess? And vendors are notorious for maybe not investing in their API documentation as well as they should. And so one of the challenges that we've had is going back to our vendors and saying, does this work like you think it does? Does this work like we think it does? And that's kind of been a big lesson learned, making sure that we all get on the same page. The second is a 3D space, and like a two-story mall is much harder to do that analysis of triangulation than a 2D space. So we're working through that and figuring out how to do that, but that's taken some time and investment that we maybe didn't expect initially. The other challenge that we have here is for Wi-Fi analytics, you have to have lots of different access points to do that triangulation. That means that you have to have more Wi-Fi sensors or Wi-Fi access points acting as sensors, which means that you have more complexity. You have to query or get data from more devices. And that means that there's some decisions to be made. First, do you get real-time data, streaming data from the access points using APIs, or sort of mini batch or micro batch, or do you just grab the data in bigger chunks over the course of the day? So those are all design decisions that there's not necessarily a bad one, but depending on your use case, you need to be careful about how you get the data and process that data. And my suggestion is focus on the data and what you want to do with the data first, and then figure out how do you need to implement it. Make sure you have really good requirements on the business case, and then back into the technology. Another lesson learned comparing sort of the APIs for location on access points, they're a very different type of API than what's on our mobile phones. Mobile phone location APIs are great. There's GPS, they're simple to use. Network device location APIs are still in a lot of churn. And I think we're going to expect to see that churn probably for 2, 3, 4, 5 years. So just be careful when you're developing on network device APIs for location that you can pivot when your upstream vendors pivot. Any questions on that? All right, so let's move to the next slide.
Hey, Alex, just wanted to give you a time check. We've got about 8 minutes.
Yep. So, and we'll do these last 2 slides very quickly. So as you use APIs, and for some reason the screen is advancing, but we'll go to the paper copy. As you use APIs, one of the first things that I always recommend people doing is figure out your identity strategy. APIs generally have to be used with user credentials, and as individual users leave the company, as you have people join the company, the life cycle of credentials for APIs can become challenging. There's been many times in my life where a scheduled task stopped working because someone left the company and there was a script using his credentials to do something important. So make sure that you really care about identity for your APIs, and that it really talks about what's your life cycle of your API, what's your out-of-band management for it, and things like that. I would also suggest looking at some of the open source tooling that's out there for APIs. There is a ton of open source tooling out there. Don't underestimate the power of PowerShell on Windows and the Linux shells, along with sort of the lightweight scripting programming languages like Python. They can develop, implement, use APIs incredibly quickly. I would also probably warn you that some of the APIs out there are really bad. I'm looking at SAP. So just be aware that some APIs are going to be easy to use. Others will take quite a lot of investment to integrate and to get the business value that you need from them. And next slide, I just covered that one. Great. So as you create APIs, once again, identity is really, really important. Make sure you know who is, make sure you have a service account, or make sure that you know the who of how you're interacting between your API elements, either server side or client side. And the other challenge that I think I didn't realize about APIs was everything that we've developed the last 20 years to secure websites is also needed to protect APIs. Things like web application firewalls provide API protections. API gateways that cloud providers have provide API protections. So make sure that you're engaging with your security team early if you're developing APIs, because that will really avoid some of the pain that they'll identify if you go into production with new APIs without involving them. The biggest thing that I can suggest from an API creation standpoint, use standards that are out there like OpenAPI. This used to be called Swagger, but OpenAPI is a ecosystem and a tool chain to create APIs, to consume APIs, and to automatically generate code to interact with APIs, in addition to documentation. Also, be really careful about not designing APIs that give out too much information. In a previous life, I created an API not realizing that a really smart attacker could combine two different APIs and get the exact thing that I didn't want to expose on the public internet. And to that point, use API gateways. The cloud providers have excellent ones, but there's on-premise ones as well. And with that being said, I really appreciate your time listening to Scott and I today, and look forward to a little bit more questions if you have them.
Thanks, and my apologies. You gotta love technology that I lost sound, so my apologies for not advancing the slides. But great job, guys, and we've had questions along the way, and I know that one of the comments that we had here is that scenario 5, that last one is a great example of work for scenario that can be leveraged for a bunch of other uses, for like store traffic, even loss prevention, safety, facility validation of deliveries, forecourt traffic modeling. Just a great way to leverage all that data.
Absolutely.
So,
and getting the information from lots of different sensors and then slicing and dicing is really going to be the future of how we all make decisions. And starting to invest in that type of technology now will pay off in the long run.
Yeah. Yep, and putting on my Conexxus data security hat, of course, everything needs to be implemented safely and securely. And so just make sure that you're, as you gave a great example, you've got to dot the I's and cross the T's and make sure that those implementations are spot on, and that you're doing your risk analysis and your assessments and so on and so forth to make sure that they are secure. So just want to thank again, Alex and Scott from SageNet. And if you have any questions there, you can follow them. And here's the Conexxus information as well. And please complete the survey that you receive upon conclusion. And we want to thank everybody today for attending. and look forward to next month. Thanks and have a great day.
Thank you.
Thanks, everybody.